In this lecture video, I am discussing about the NGP. NGP means neighboring group participation in free radical substitution reaction. And in free radical substitution reaction, already one video as uploaded. First try to see this first video. And in free radical substitution reaction, there are three steps: chain initiation, chain propagation, chain termination. Actually, what happens in this free radical mechanism, suppose Rx, this is reactant substrate, change into product Y, Ry, by free radical substitution mechanism. Then what happens here, this Rx substrate spontaneously, means in presence of light, in presence of organic peroxide, or at due to high temperature or due to gas phase, it spontaneously itself dissociate to give R radical and X radical, or this is called cleavage step. And another step here, if there is presence of another free radical, then this another free radical abstract X from this reactant substrate to give XW product, and here formation of R radical, and this is cleavage step for the formation of free radical, and this is abstraction step for the formation of free radical. And next step, what is the possible mechanism? This R radical react with reagent. Suppose here reagent YW and here R radical, and what happen in free radical mechanism, always free radical abstract radical from neutral species, and this is when this R radical abstract Y radical from this reagent, then give Ry product, and in reagent there is a formation of free radical W radical. Our product is formed by R radical is formed by cleavage or abstraction. Abstraction takes place in presence of another radical, and cleavage takes place spontaneously. What is the meaning of spontaneous? In presence of organic peroxide, or in due to high temperature or due to gas phase, when molecule itself dissociate to give radical, this is called cleavage or spontaneous. And abstraction and product is formed by either when R radical react with neutral reagent, then what happen, R radical abstract Y from this neutral reagent to give Ry neutral product, and W radical is generated, or when this YW reagent itself spontaneously dissociate to give cleavage to give Y radical and W radical, then this formed R radical combine with Y radical to give Ry product. This is free radical mechanism in aliphatic substrate. And in free radical mechanism in aromatic substrate, I have already discussed. And now come to the NGP, neighboring group participation in free radical substitution reaction. But here first try to understand what is NGP or neighboring group participation. Actually, neighboring group participation also involved in nucleophilic substitution reaction. And when we observe in nucleophilic substitution reaction, and suppose we take here CH3, CH2, CH2, Br, and when we react this molecule with OH minus, aqueous, and here aqueous OH minus act as a nucleophile, and when here this aqueous OH minus react with this substrate, what happen in nucleophilic substitution reaction? CH2, CH2, OH plus Br minus. Here one nucleophile substitute another nucleophile, therefore this is nucleophilic substitution reaction. And when we take another example, suppose CH3, here S, here CH2, here CH2, here Br, and when we react this molecule with OH minus aqueous, there is also nucleophilic substitution. Here this bromine is electron withdrawing, it withdraw electron density towards it and it develop negative charge with this carbon positive, and this OH minus attack on this positive charge carbon and it gives CH3S, CH2, CH2, here B are removed and this nucleophile attack on this CH2 carbon and give Br minus. This is also nucleophilic substitution, this is also nucleophilic substitution reaction. Here sulfur contain 2 lone pair electron, but when you observe rate of reaction, this second, this is first, suppose this is second nucleophilic substitution. In this second nucleophilic substitution rate of reaction is 600 times faster, 600 times faster than this first nucleophilic substitution reaction. And here why abnormal high rate of reaction? Due to neighboring group participation. Now come to what is neighboring group participation. Neighboring group participation means here in this molecule, in second molecule, in this substrate, due to this presence of sulfur, here this sulfur contain how many 2 lone pair electron, and this sulfur having lone pair electron act as a neighboring group, and neighboring group involvement takes place when this lone pair electron containing group are present at alpha, beta, gamma, delta position. And when we react this molecule with OH minus aqueous, this carbon is more closer with this lone pair electron than that of this incoming nucleophile. And here this nucleophile also contain lone pair, this neighboring group also contain lone pair, but which one is easily available? This neighboring atom containing lone pair electron is easily available to this CH2 group. Then at first this lone pair easily attack on this CH2 group, and when this lone pair attack in this CH2 group, what happen here? It gives CH3 here. Now see here what happen here, CH3 group S, CH2, 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 and this positive, when Br minus removed here, when this Br minus removed, and then when Br minus removed, then what happened? This positive charge shift into this sulfur, and here formation of 3-member cyclic transition state and 3-member ring are highly strained, and it try to change. Then what happened here? Here what happened? There is ascent to reaction mechanism. There is ascent to reaction mechanism. Here simultaneously lone pair when attack on this carbon, Br removed. Therefore this takes place simultaneously. When this neighboring pair attack on this CH2 group, there is outgoing nucleophile removing, therefore ascent to. In ascent to what happened? There is inversion. Inversion. Again when, and next step what happen? When the cyclic transition state is formed, again OH minus attack on this cyclic transition, and this OH minus either attack to this carbon or this carbon, because both are same. Suppose when this OH minus attack on this CH2 carbon, then this positive charge sulfur attract this pair electron towards it. When this attract this lone pair electron towards it, then here sulfur already contain 1 lone pair. When this lone pair shift towards this sulfur, this positive charge neutralize and positive charge shift to this CH2 group, and this positive charge combine with OH minus and give product. Here Br minus substituted by OH minus. This is also nucleophilic substitution reaction. and due to this pair of electron, here nucleophilic substitution reaction is 600 times faster than this first. This is neighboring group participation in aliphatic nucleophilic substitution reaction. And here in second step, what happen in first step, due to ascent to reaction mechanism in the formation of this cyclic transition state, here inversion, again nucleophile, this nucleophile when attack in this CS2 group, this pair remove shift towards the sulfur, this is also simultaneously happen. Again there is another, when nucleophile attack on this cyclic transition, when OH minus attack to this carbon, at the same time there is a removal of this pair of electron towards this sulfur, and there is another ascent to reaction mechanism. And when 2 times ascent to reaction mechanism takes place, then there is retention of configuration, means in neighboring group participation there is always 100% retention, there is no inversion. This is the strong evidence behind neighboring group participation in nucleophilic substitution reaction. And next example, see here what is the evidence behind the nucleophilic substitution reaction. One strong evidence, suppose when you take this molecule, suppose this molecule here CH3 group, this is evidence of nucleophilic substitution reaction. This is strong evidence for MSc level students. Here CH3 and here OH group, and here Br, here H, suppose, and this one of the compound, this and another compound, see here another compound, suppose when we take this OH, here Br, H, both molecule are same, molecular formula same, but structure different. Methyl same, here OH group, here Br group, and another when you draw the mirror image of this compound, it give HO, H, and here Br, mirror image HBr, here CH3, CH3, and when this group in opposite side, this is having this Beer group in opposite side, this is 3O, 3O DL pair, this is 3O DL pair. When this group in the same side and another molecule, when we draw mirror image, here H, here H, here Br, here OH, here CH3 group, here also CH3 group, this is 3O, this is erythro, and this is erythro, this means this is meso. Here both group in same side, this is optically inactive, but this 3O-DL pair is optically active. Here this group are in opposite direct side. In this molecule there is same side, and when we react this molecule with HBr, hydrogen bromide, when we react this molecule with HBr, what happen here? This 3O-DL pair, HBr react with this molecule, and suppose there is nucleophilic substitution reaction, Br substitute suppose OH minus, and when this Br substitute OH minus, then give this product, and what happened in this product, there is also formation of DL pair. Optically active give optically active product, and here what happened, when we react this molecule 3O-DL pair, optically active erythro DL pair give DL pair product, optically active product, and when we react with erythro means optically inactive compound, here hydroxy group replaced by Br, hydroxy group replaced by Br, this is meso DL pair. And what we have discussed in the mechanism of neighboring group participation, in neighboring group participation there is always retention of configuration, means there is 2 times ascent to 2 times inversion, that is retention. Here here what happen, 3ODL pair optically active give optically active product, means there is retention of configuration. Erythro means optically inactive give meso means optically inactive, and this is the strong evidence behind the neighboring group participation and nucleophilic substitution reaction. If you understand this neighboring group participation in nucleophilic substitution, then now come to the NGP, neighboring group participation in free radical mechanism. And here this is general free radical mechanism in aliphatic substrate. And what is the evidence of neighboring group participation in free radical mechanism? And when we carry out photolytic halogenation, when we carry out free radical bromination in presence of light, give mixture of many products, doesn't give single product. But however, bromination of carbon chain containing a bromine atom, when you observe in this molecule, this carbon is optically active. What is optically active, or what is chiral center? Carbon atom bonded with 4 different groups, and here this central carbon bonded with CH3, one group CH3, another C2H5, another hydrogen, another group CH2Br, and that this carbon contain all 4 different groups, therefore this is optically active. And here at the proper position there is neighboring group bromine atom, here bromine atom containing lone pair electron. And the however here photolytic halogenation give mixture of many products, and simply when neighboring group does not participate, and when we carry out here bromination in presence of light, H mu means this is homolytic halogenation, either this hydrogen is replaced by bromine, or from this CH3 also this Br radical bromine substitute hydrogen, or bromine also substitute hydrogen from the C2H5 group. But what happened, this hydrogen is substituted by bromine in this compound, this hydrogen is substituted by bromine to give 84 to 94% product. But actually this bromine is electron withdrawing group, and electron withdrawing group always decrease rate of free radical substitution reaction. But here what happen, due to presence of this bromine, here rate of reaction is very high. And what is the condition of neighboring group participation? High rate of reaction. When a chemical reaction show abnormal high rate of reaction, there is neighboring group participation. Again, when reactant molecule contain lone pair electron containing group or neighboring group at alpha, beta, gamma position, then there is neighboring group participation. Again, reaction is only feasible. Reaction neighboring group participation is only feasible when 3 member, 4 member, 5 member, 6 member cyclic transition state is formed, which is shown in the above example in nucleophilic substitution reaction. And retention, when retention of configuration takes place in product, this is the evidence of neighboring group participation. And smaller the ring size, suppose there is 3 member and 6 member cyclic transition intermediate, then which one more reactive? 3 member cyclic transition state containing intermediate is more reactive. And when you observe in this molecule, due to this electron withdrawing group, strong electron withdrawing group always decrease the rate of reaction. But what happen in this molecule, however bromination of carbon chain containing a bromine atom occurs with high ratio selectivity, mean especially here 84 to 94% substitution takes place in this hydrogen. And why? This is due to neighboring group participation, and this is the strong evidence behind the neighboring group participation in free radical substitution reaction. And what happen in this molecule, when we carry out photolytic bromination or bromination in presence of light. In presence of light there is free radical mechanism, and when always what is the actual mechanism in first video say always radical abstract atom from neutral species, and this is reactant molecule, this is neutral, and this Br radical at first try to abstract this hydrogen, and when this bromine starts to form bond with this hydrogen to abstract from here carbon hydrogen bond starts to dissociate. At the same time, due to presence of this lone pair electron containing bromine, it forms cyclic transition state. And when this Sbr removed from here, this bromine radical abstract here hydrogen radical, and here in carbon there is formation of Br radical. Sbr molecule is removed, and this gives cyclic transition state. This free radical shear in between this bromine, carbon and carbon gives such type of cyclic transition, and this is 3-member cyclic transition state is formed, and this act as a free radical. And next step, what happened from Br to this radical abstract bromine. Br radical from this Br2, because it act as a radical always abstract radical from neutral, and when this radical abstract Br, what happen here in Br, when this Br2 molecule dissociate by homolytic bond fission to give 2 Br radical, this Br radical attack on this carbon, then this in this pi bond there is also homolytic bond fission, then it give free radical, bromine is regenerated, and here this carbon form radical, this radical combine with Br radical to give this product, and substitution takes place in this carbon. Simply you can show in this way, and this act as a radical, and this radical abstract Br from this molecule, this radical abstract Br from this Br2 molecule, and there is Br radical byproduct, and here what happen in this product, there is a retention of configuration, means always here incoming Br radical attack in this carbon. Therefore, due to presence of this neighboring group, here rate of reaction is very high with compared to the other photolytic halogenation reaction. So in free radical there is also neighboring group participation, and here neighboring group participation in free radical this is completed, and next video I will discuss about the reactivity for aliphatic substrate and aromatic substrate in free radical substitution reaction. Similarly, next chapter reactivity at a bridgehead, there is another topic, reactivity at bridgehead. Okay, now in this video this much.